All right, in this question, the big idea is an input-output table. This right here is the input-output table. To finally get the answer at the end, we're going to use the strategy guess and check, which we've used before. The first thing we have to understand is all these points, 1, 5, 2, 8, 3, 11, 4, 14, 5, 17, have an x value and a y value, an x coordinate and a y coordinate. And it's x first, then y, just like alphabetical order. So let's just take these numbers from these points and put them into this table. So like 1 would be the x, and 5 is the y. 2 is the x, and 8 is the y. And we're just going to do that for all of those points to make this input-output table. All right, so it turns out that there's a relationship happening here between the value of the x and the y. So there's a relationship happening between 1 and 5 and 2 and 8 that happens for all of these. We have to figure out what is that relationship. Okay, so at this point we're going to use guess and check. The equations are going to try to show us what the relationship is. So if we look at the first answer, first possible answer, it's y equals x plus 2. So this is basically saying to get the value of the y, you have to take the value of the x and add 2 to that. So we could test this by putting in 1 for x. So the x is a 1, and so y would equal 1 plus 2. 1 plus 2 is 3, so we're saying if x is 1, the y would equal 3. But that's not true, y equals 5. So it doesn't work. If we tried it for this value, we would plug in a 2 for x, and 2 plus 2 is 4. We would expect this to be a 4, but it's not. So this is not the relationship that's happening. Okay, so let's guess the next relationship. And the equation says y equals 2x plus 1. Now it's important to understand that when it says 2x, that means 2 times the x value. So to test this, we'll do 2 times the x number, which again we're going to use 1. And then after that, we'll add 1. Now, if this equals 5, maybe we're on to something. Okay, so what is 2 times 1 plus 1? 2 times 1 is 2, plus 1 is 3, but not 5, so I don't think we've got it. We can test it again for any one of these x numbers. We'll take this 2 right there. So we'll plug in a 2. Now, if we get 8, maybe we're on to something. 2 times 2 plus 1 is what y equals, but that is not 8. That would be 5. So it doesn't look like that's it either. Okay, so let's take a look at the next equation. Y equals 2 times x plus 3. All right, so let's see if this is the one. So again, 2x means 2 times x. In this case, it would be 2 times 1 plus 3. Now, if this equals 5, that's a good sign. Let's see if it does. 2 times 1 is 2, plus 3 does equal 5. Okay, so maybe that is the relationship. Maybe the relationship is to find the y. You do 2 times the x number and then add 3. But it's not good enough for it to work once. It's got to work for all of these values. So now let's try the 2. If this equals 8, that's a good sign. Let's see if it does equal 8. 2 times 2 is 4, plus 3 is not 8. That would only equal 7. So even though it worked once, it didn't work all the time. Let's try the next one to see if it works all the time. And we've got y equals 3x plus 2. Okay, so first we'll try the 1. And 3 times 1 plus 2. See if it equals 5. 3 times 1 plus 2 does equal 5. But again, it's got to work for all of the inputs and outputs. So now we're going to try the 2. We're going to try 3 times 2 plus 2 to see if it equals 8. Sure enough, it does equal 8. Let's see if it works all the time. Let's try a 3 now. So 3 times x plus 2. The x is 3, so 3 times 3 plus 2. That equals 11. Check that out. It's working every single time. What about if we tried 3 times 4 plus 2? Would that equal 14? It does. Check. What about if we tried 3 times 5 plus 2? 3 times 5 plus 2. Would that equal 17? It does. So this is the rule that works for all of the inputs and outputs. So whatever the x number is, If you triple it and then add 2, you'll get the value of the y. Triple this and then add 2. 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 It works every single time. This is the equation that shows the relationship between the x and the y. And we could see that in the input-output table. And we just guessed the equation and checked it by plugging in the x numbers to see if they worked.